Hello guys and welcome back. Today we are going to talk about parallel circuits and voltage drop in parallel circuits. Parallel circuits are probably the type of circuit with which most people are familiar. Most devices such as lights and receptacles in homes and office buildings are connected in parallel. Imagine if the lights in your home were wired in series. All the lights in the home will have to be turned on in order for any light to operate. And if one were to burn out, all the lights will probably go out. The same is true for receptacles. If receptacles were connected in series, some device will have to be connected into each receptacle before power could be supplied to any other device. In a parallel circuit, the total current flow in the circuit is equal to the sum of the current through all of the branches. This is known as current adds, as in adding the current. Voltage drop. Another parallel circuit, the voltage drop across any branch of a parallel circuit is the same as the applied voltage. Total resistance. The total resistance of a parallel circuit is always less than the resistance of the lowest value resistor or branch. In the circuit, each time another element is connected in parallel, there is less opposition to the flow of current through the entire circuit. Imagine a water system consisting of a holding tank, a pump, and return lines to the tank. Although the large return pipes have less resistance to the flow of water than small pipes, the small pipes do provide a return path to the holding tank. Each time another return path is added, regardless of size, there is less overall resistance to flow, and the rate of flow increases. That concept often causes confusion concerning the definition of load among students of electricity. Students often think that an increase of resistance constitutes an increase of load. An increase of current, no resistance, results in an increase of load. In laboratory exercises, students often see the circuit current increase each time the resistive element is connected to the circuit, and they conclude that an increase of resistance must, therefore, cause an increase of current. That conclusion is, of course, completely contrary to Ohm's law, which states that an increase of resistance must cause a proportional decrease of current. The false concept that an increase of resistance causes an increase of current can be overcome once the students understand that if the resistive elements are being connected in parallel, the circuit resistance is actually being decreased and not increased. Parallel resistance formulas. Three formulas can be used to determine the total resistance of a parallel circuit. Parallel resistance formulas in resistors of equal value. When all resistors are of equal value, the total resistance is equal to the value of one individual resistor or branch divided by the number of resistors or branches. Therefore, the formula RT equals R over N, or the number of circuits or resistors, applies. Second formula in parallel resistor formulas is product over sum. This formula determines the total resistance in a parallel circuit, and it divides the product of pairs of resistors by their sum sequentially until only one pair is left. This is commonly referred to as the product over sum method for finding total resistance. So the following formula applies. RT total equals R1 times R2 over R1 plus R2. Third is the reciprocal formula. This formula used to find the total resistance of a parallel circuit is 1 over RT total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn, or the number of circuits. Notice that this formula actually finds the reciprocal of the total resistance instead of the total resistance. To make the formula equal to the total resistance, it can be rewritten as follows. R total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. The value Rn stands for the number of resistors in the circuit. If the circuit has 25 resistors connected in parallel, for example, the last resistor in the formula would be R25. This formula is known as the reciprocal formula. The reciprocal of N number is the number divided into 1. The reciprocal of 4, for example, is 0.25, because 1 quarter equals 0.25. Another rule of the parallel circuits is the total resistance of a parallel circuit is the reciprocal of the sum of the reciprocals of the individual branches. The amount of current flowing through each resistor is inversely proportional to its resistance. So when we discuss the characteristics of parallel circuits, we stated 3 rules for solving electrical values of parallel circuits. Solve for missing values in a parallel circuit using the 3 rules and Ohm's law. Discuss the operations of recurring divider circuit and calculate the current values using the current divided formula. Thank you for watching, guys, and please, if you like my videos, like, share, and subscribe. See you in the next one.